Previously, you have been introduced to the types of systems, open and closed systems, and the properties that are used to describe the state of the systems. Now, a system and the information of the properties will not be interesting unless it undergoes a process or a series of processes. So here, a process is a succession of states which the system has passed through. It could just be one process or many processes, but a process involves a succession of states which the system has to go through. There will be many types of processes you will encounter in this thermodynamic analysis of systems. Yes. Isothermal process will be one process where there is no change in temperature during the process. That means if you have a tank of fluid that has undergone a process, then you would not have any change in temperature before the process began and at the end of the process. Isobaric process, no change in pressure during the process. Isochoric process, no change in volume during the process, like the expansion, of the frictionless piston cylinder system. A cyclic process consisting of a series of processes such that the beginning and end states are the same. So a cyclic process consists of two or more processes, closing the loop. Adiabatic process, no heat entering or leaving the system. When you have an open or closed system that has been perfectly insulated, it is good to assume that it has undergone an adiabatic process. Then there is polytropic process. PV⁴n is a constant. That means before the process began, the pressure, the initial pressure, the initial volume to the power of the index n is equal to the pressure at the end of the process multiplied by the volume to the index n. N can be any number. Quasi-static process is where the change of the system properties during the process is negligible. That means if you have initial state going to the final state, you know all the properties at the initial state. But a process, as mentioned before, is a succession of states from here to there. So this succession of states cause a change in the system properties, but the change is negligible. So you may ignore the change. That is quasi-static process. Reversible process is when a system and its surrounding can be returned to its initial state before the process began. So let's say at the initial state, you know the properties. You have the density, pressure, temperature, etc. And then it has undergone a process to the final state. And you also know the properties at that instant. Now you can get back to the initial state through the same path. Remember, this is not the same as having your hot coffee cool down and heating it up in a microwave. And you say that the cooling down of the coffee is reversible. No, that's not it, because you have used external force, in this case electricity, to heat it up. So that is not a reversible process in its true sense. Now, irreversible process is the opposite of it. Okay. It's a question for you to ponder in your notes. We go to property diagram. It's a diagram with properties as coordinates which show the process. So here we have two properties, pressure and volume, and here temperature and volume. So this is a property diagram PV, a property diagram TV. So note here in the PV diagram, these will be the constant pressure lines, the blue horizontal, and this one will be the constant temperature lines. And if you have your system undergoing a constant pressure process, let's say at a particular P4 perhaps, then it would follow the constant pressure line if it's an isobaric process. If it's an isochoric process, then it will follow this green line straight. It cannot detour anywhere else. And if it's a constant temperature line, it will follow this line. Same goes with the TV property diagram. So you have the constant pressure line, yeah, P1, P2, P3 and so on, where P5 is higher than P4, higher than P3 and so on. So you have here, this is the red line is a constant temperature line. Compare that with the one on the PV diagram. And the isochoric process is the same. But the isobaric process here, here is a straight line, whereas on the TV diagram, it follows this curve. So be aware of those lines. Now, a thermodynamic cycle is when a system in a given initial state goes through a number of different changes of states or processes and finally returns to the initial state as shown in this schematic diagram. So you have the working fluid, yeah, at this initial state going to state 2, state 3A, state 3 and state 4 and back to state 1. That is a cycle. It's a complete cycle. We have processes 1, 2, 3, 4, 5 processes involved. Yeah. So the properties at the beginning and end of the cycle, in this case, let's say this location, are the same. Yeah. This is an example of a steam power plant processes involved. Yeah. Now, how many properties do we need to describe the state of the system? We mentioned earlier that state of the system at any particular instant can be described by its properties. So how many is enough? And if you have, let's say, 1 or 2 or 3, can you find the rest? You know, if you know only the pressure and the temperature, can you find the density? Yeah. So here we utilize the state principle or the two-property rule, which states that the state of a simple and compressible system may be determined with two independent intensive properties. Now, earlier in part 1 of the module, we've been introduced the meaning of intensive and extensive properties. So the state principle requires that knowledge of two independent intensive properties are known. So that means if you have these two independent intensive properties, you may get the rest of the properties. Simple, what does it mean to be simple? That is without any electrical, magnetic and other external effects. Compressible, the volume changes due to pressure, temperature or other factors. Generally, fluids are compressible, even water or even liquid. Independent is when one property is held constant and the other can be varied. We'll see this under certain condition. Yeah, pressure and temperature are not independent of each other. Otherwise, they are. Okay. So for the units, we have the primary unit, the length, mass, temperature in the SI system, yeah, metric system. And the secondary unit are those derived, like the energy in joules, yeah, what is joule per second, pressure, etc. We are going to utilize the metric system throughout the thermodynamic analysis in this course. So English system are probably still being used in some other parts of the world. Because the English unit, their primary unit consists of the time, the length, the mass, and the force. Whereas in the SI unit, only 3 basic units as time, mass, and the length. Okay. So specific volume, you know about density, that is kilogram per meter cube, but we deal a lot with specific volume. It's an intensive property, it's in meter cube per kilogram. Okay.